What's up, dude? Hey, Andrew, why do we do related rates?
Well, Sharaz, the reason we do related rates in calculus and physics is to involve the rate of change in quantities with respect to time implicitly.
Oh. Okay, so let me tell you guys about the process of related rates. 1, draw a picture.
2, label the picture.
3, write out your given quantities.
4, write out what you need to find.
5, write out the equations you will use.
And 6, solve the problem.
Let's do it!
Alright, so for our first problem, it's a ladder problem. The problem is a 20-foot ladder slides down a wall at 5 feet per second. At what speed is the bottom sliding out when the top is 10 feet from the floor? So we follow our procedures. So first, we draw our picture. This is the wall. Here's the ladder. And then we label the picture. The ladder is 20 feet and it's a constant. The wall is 10 feet. And this is X. This is Y. And this is C. And the ladder is falling down at 5 feet a second, so dy dx will be -5. And then next, you write your givens. Y is 10. Dy dt is -5. C is 20. And we write what we have to find. And we're trying to find the rate of x sliding away from the wall. So that will be dx dt. And now we write down the equations we will be using. And the first one is x squared plus y squared equals c squared because it's a triangle. And then we derive this problem and we'll get our second equation. 2x dx dt plus 2y dy dt equals 2c dc dt. And now for our work. First, we have to try to find what x equals, so we plug in all the variables for the first equation. So x squared plus y is 10, 10 squared equals c is 20, 20 squared. So x squared plus 100 equals 400. Solve for x, and x will equal the square root of 300, which is about 17.321. And now we plug in our variables into the next equation. And to simplify this equation, we can first divide everything by 2. That way you get rid of all the 2's. So x dx dt plus y dy dt equals c dc dt. So you plug in x, which is 17.321, and you're trying to find dx dt. Y is 10, dy dt is -5, c is 20, and it's a constant, so it just equals 0. And now you solve for dx dt. So you divide the 17.321 over, and dx dt will equal about 2.887, and that's how you solve this problem.
Okay, so this next related rates problem we're doing, it's a bit tougher than the last one. And so the question is, gravel is being dumped from a conveyor belt at a rate of 20 feet cubed per minute, and it forms a pile in the shape of a cone whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? Okay, so first we draw our picture. And we'll label our picture too. This is our height, which equals 10 feet. And our diameter also equals 10 feet. And so we have a conveyor belt that's dumping in stuff into this cone. And so we want to write down our given quantities. And so given is, so our rate of the gravel being dumped is going to be dv dt, which equals 20 feet cubed per minute. And then since our height equals the diameter, that equals 10 feet. And what we want to find is the rate at which the height is changing. And so that is going to be our dh dt, which will equal something feet per minute. Okay? Now the equation we're going to use is volume equals 1/3 pi r squared times the height. And since 2 times the radius equals the diameter, that will equal the height. So we can write this in terms of h, since we have a given h. So volume will equal 1/3 pi h over 2 squared times h. And when we solve this all out, we get pi over 12 times height cubed. Okay, and so now for our work, you've already seen this, so I'm going to erase all this. Let's write all this stuff right here. Volume equals pi 12 times h cubed. Okay, so for our work, we're going to have dv dt, which is going to be the derivative of volume, which will equal pi over 12 times 3h squared times dh dt. Okay? And so now we're going to plug in our quantities, and we'll get 20 equals pi over 12 times 3 10 squared times dh dt. Okay? And so now we'll try to find our dh dt. So dh dt equals 20 all over pi over 12 times 3 times 10 squared, and our dh dt approximately equals 0.2546 feet per minute. And that is our final answer. Hey Andrew, dude, I get related rates now.
Dude, me too, Sharaz.
Get